So I'm very excited again to be with you here one more time. We have today in our talk more than 40 people registered, but I see people maybe are coming a little bit late. The topic of today is Azure's AI Symphony, orchestration, embeddings, and more, which shouldn't be understood in the literal sense, the same as the picture I generated, of course, with DALL-E on the bottom right, but it's just, well, to make it a little bit a funny title. With us, we have Ioannis Kosaris, and my name is Carlos Hernandez Vaquero. GenAI Gurus is a community which started not long time ago, just a few months ago, but as probably you have seen, we are already more than 500 people. And it's open for both newcomers and experts to all of us become gurus of generative AI. And the intention is to help us learn in a guided way from basics to advanced, using all kinds of hands-on concepts and also other non-technical topics we will see later on. As you see, we have a lot of upcoming events. On Monday next week is the community call, which happens once per month. This is the place anyone can join to influence the community, to contribute to the community. And we have two very interesting talks probably happening in December. Concrete date will be announced soon. We will have a deep dive into Pandas AI. If you have used the Pandas library from Python, probably you know what is this about. But of course, using natural language, very interesting topic. And also we will have the Leo LM, which is the first German-speaking LLM. But also can be generalized for other languages. So Björn Kluster from University of Hamburg will talk about that. And also we are planning a lot of hands-on live free courses. So you maybe have seen in LinkedIn, we are searching for generative AI course instructors. And we will start from the basics, just using the OpenAI APIs, but also prompt engineering. I hear some weird noises. I hope I'm still audible. Also, we will look into fine-tuning LLMs, building complete generative AI apps, ethical generative AI, and much more. And this community is pushed mainly by 4 people. So I'm Carlos Hernandez Vaquero. I see more people joining. And I'm a software development manager leading the data-centric software team at Bosch. I'm also a Microsoft Learn Student Ambassador, which is very good fit for this talk of today. And also organizer of the TensorFlow user group in Germany, and the official mentor, or one of the official mentors in the deep learning specialization from Andrew Ng in Coursera. We have also Selina Singer. She's doing global advisory on risk management for GenAI from KPMG. Gerd Prusman, CTO from Cloud Ace in Berlin. Rasmi Kamat, data scientist, freelancer, which I guess they will join in a few minutes. And what we now come to the interesting part, the speaker of today, Ioannis Kosaris. He's a software engineer at Microsoft, specialized in machine learning systems. His innovation in collaborative systems, data storage, and natural language processing are his main motivations. And he's doing a lot of ML orchestration systems, intelligent context-aware ML agents, etc. Now, what I'm very curious about what is this task force at Microsoft, but he's playing a key role dedicated to pioneering applications in generative AI. And of course, he is here because his passion is sharing knowledge about ML systems. And with this, I pass it to Ioannis. The stage is yours.
Thanks a lot, Carlos. And thank you for having me as well. I think we have a really cool community here. It's really great to see like some disambiguation going on in the ML space right now. With how things are going, like we get overloaded with information, and I think it's really important to actually get a place where you like get the information feed and you understand those concepts and you can talk with others about them. Yeah, about the task force, about the work I'm doing. I hope I'll be here again someday, actually showcase and announce what Microsoft has been working on. But right now, I'm going to talk to you about Azure's AI Symphony, orchestration, embeddings, and I'll jump right into what we're going to talk about. And we'll do some disambiguation first, right? Let's break down what this orchestration and what we mean by ML systems. So essentially, what we'll do today is frame a demo machine learning application. We will be focused on generative AI, of course. And then through that problem, we will break it down and find Azure solutions to prototype this problem with. We'll use essentially all the tools in our toolbox. And we'll use Azure exclusively for that. Then, having all those tools and having prototyped the problem, we're going to do some like systems design and understand how all these tools orchestrate together to form a production system, something that we can actually create and deploy and even scale in the future. And we'll talk about some of the key parts of those systems, classification and embeddings. And then we'll conclude with some of the systems considerations around like that intersection of scale distributed software systems and the new infusement of machine learning into them. What are the new things that software engineers at least have to think about nowadays with those types of systems? So just to reiterate, we'll focus on this narrow part of artificial intelligence, which is generative AI. And I just want to clarify that because like on the left, this is what usually my Twitter feels like nowadays with AI. So like words thrown at you. So some people are like proficient in those, others are getting to dip their toes on that domain, especially like with all the stuff happening around startups nowadays. Yeah, it's been a bit crazy. So we'll focus on this narrow part that's called generative AI, and we'll focus on how generative AI applications work and orchestrate with Azure. So first things first, I think that's this picture should be very familiar to everyone that's ever worked with LLMs, essentially. And it's about like what a large language model does, what most AI models do. You have a prompt. You may break this down into complex tasks. We've seen this with OpenAI and the APIs they have. And essentially, you have an input and a completion output. And that's really important for us because like for system design, we need to understand that central part of this system. And now we'll jump into actually creating a problem for ourselves to solve. And I thought a bit of what we're going to do today. I knew that we have people from different domains here, and I didn't want to create a problem maybe in the supply chain area or business areas or consumer. So found something a bit out there. We're going to create an AI content creator today. And we'll orchestrate this and we'll put it in a system. So this is a bit like a weird use case, but I hope it integrates a lot of like ML capabilities. And we're going to break it down into the following steps, right? We want this application to watch a video, plan what to say for each sentence, convert its response to speech, and voice and animation. That's our like demo application. So it will actually simulate watching this video. It will react and infuse a couple of interesting stuff on that. And I've broken down what we need to do in terms of Azure products. We have to do speech to text, of course, or video to text, of course. And we can use Azure ML and OpenAI Whisper for that. Or we can even use Azure speech to text. And then we have to read those prompts. We'll use Azure OpenAI for that to leverage GPT actually. And we'll get into the language studio to do some entity extraction, sentiment analysis, create a plan with GPT-4 of what we need to do next. Then we get to text to speech, maybe adjust some tone, maybe adjust the phonemes of like how the response sounds like. And at the end of the day, we have some things that I'm not going to show. I'm going to reference maybe what they are, but phoneme to animation and with Microsoft Visme and stuff like that. But we will focus mainly on like the cognitive offerings of Azure. And with that, let's start prototyping with Azure. So how do we start to dip our toes in the Azure environment and all the things that Azure has to offer us around machine learning? This is a new product. It recently came into public preview. It's Azure AI Studio. And it's very cool because it consolidates a lot of capabilities into one studio, one platform. Essentially, what I have here is I have Azure OpenAI, speech, language, and vision. And you can already see some of Meta's models here, like Llama, GPT 3.5, GPT-4, Falcon. And what AI Studio offers me is a singular place to start exploring the tools in my toolbox, right? And I'm sure you know that Azure is bringing OpenAI to the table, but Azure ML actually has a catalog as well. So I can filter for NVIDIA, Hugging Face, Microsoft research models, Azure OpenAI, Meta, and I can find the model I want. And for example, like we saw on the framing we did, let's see if we can level Whisper here, right? So we can select the model, Whisper 3 here, and it's ready for deployment. If I click deploy here, we will create a real-time endpoint. I won't do this right now. It takes a while. But we will have, as a result of deployment, in our Azure resources, a deployed model and an endpoint we can use to actually start sending inputs and getting outputs like the examples. Very easy to do. It takes a while, but in terms of like infrastructure, it's pretty easy to onboard to that. And going back to our model catalog, we can see like a lot more offerings here I can play around with. But for our current use case, we're going to use the speech capabilities of Azure OpenAI. And if I want to, what we actually want to do here is real-time speech speech to text. So going to the Speech Studio here, with those platforms, this is a different platform. It's Speech Studio. Azure AI will take you there. And I have a couple of capabilities here around speech. I can do captioning of video. I can take call transcripts. I can use the Whisper model, or I can use real-time speech to text and a bunch of other like ML solutions around speech. Right now, I will use this model, real-time speech to text, and let's prototype the first step of our application, which is actually getting like I copied a video here from YouTube, transformed it to MP3, and I fed it to this endpoint. Of course, we are prototyping here, right? We're simulating what in the future our services will do. To like input a video stream, and that feed will be taken for each audio, and real-time text-to-speech can actually work on that and start transcribing all of our text. So essentially, this is the first part. It's a documentary around hippos, I think. So this is the first step. We now have the text input from that video, and we can feed that to our model, and we can do it phrase by phrase if we want to have a continuous stream of data, or we can feed it as a chunk of text. So the next step after we have those parts is to analyze this input and give our LLMs a bit more context around that piece of text. And you might hear that as retrieval augmented generation. Like RAG is the term people use to describe how you actually feed the LLM with a prompt, but you actually retrieve other data sources to enrich that prompt and make your model reply better or align better. So we want to, based on that text, get some analytics out of the text, and that will be actually useful to that ML model. So for that, again, I can go to language here and see my language capabilities. And going into Language Studio, the first thing I'll do is some sentiment analysis and opinion mining on that. So I take the input phrase, and then I actually go ahead and run it, and I will get a JSON output here, which is what is the overall sentiment of that phrase, and this is a mixed sentiment phrase. Of course, I think it's Mr. Attenborough speaking here, and I also get an opinion mining per word here, which is actually pretty interesting and valuable for us here, right? Because what essential opinion mining does, it specifies that a target phrase has an opinion associated with it, and if this opinion is negative or positive. And this is very useful, not only in the example that we have, but in general in products where you have your like extracted entities. Maybe it's a product name, maybe it's a contributor you have, maybe you're analyzing a team's transcript or whatever, and you want to assign what is the sentiment towards something that interests you. So in this case, we have something not that interesting. It's the heat is overwhelming. So the overwhelming word assigns like a sentiment to the word heat. But in general, this is useful information to have and extract. And we're going to feed this in the future to our LLM with Azure OpenAI. The second thing I'm going to do is extract some named entities here. So again, in Language Studio, I'm going to use the named entities, extract named entities models, and go ahead and add the same input that we got from that transcription. And now we have a couple of named entities. Here's products, which is sunscreen, and waterfalls, which is supposed to be a location. Yeah, on product, we have a pretty high confidence score. So what could this help us with, right? What if we made that content creator advertise the products when it finds them? That seems like pretty cool. So we can use that model and say, oh, you know what? We will extract some products for you. Maybe we want to fine tune it as well to make it like our company's products, right? And once you find those words, please go ahead and like find the product in our database to advertise. And this is pretty much it here. All those models, what they will give you, and I'm not going more technical here, because this is a very, very easy to do in terms of software engineering, right? This is the other prototyping part, but if I just wanted to interact with this model after my prototyping, what Language Studio and every Azure resource will give me, even speech, is actually my endpoint, which like I hit that API with a payload, and I get that JSON response back. Like in terms of engineering, this is very easy to do. I just talk with APIs, nothing more.
Yanis, there is a short question. Yeah, sorry to interrupt you in the chat. Why does it not identify entity like animal? I'm not sure in which context. I don't know if you have a sentence which shows something with animal. I guess so.
So animals here and hippos here should be identified, right? So it has to do with a deployment, with a selected deployment I'm using here. That it's a very like lax kind of entity extraction. I don't want it to go overboard. And there are actually thresholds as well that I can set, like, oh, you know what? I don't want like things that may be like lower than 50% classified and stuff like that. What I would do here, because those extraction models are pretty useful, but they're great use because like LLMs could do that as well, right? But their important use comes from fine-tuning those. And in Language Studio, you can actually, we are using extract named entities here, right? There is a custom named entity recognition. And what custom means is I can feed it like maybe my company's data, and now it understands, like it tries to abstract and understand the context of my company. There's no LLM behind this entity extraction endpoint though. This means it's very fast as well in terms of like actually getting you that results. But this is a very relaxed version of this model. I don't know if that answers your question. If it doesn't, please follow up. So I'm gonna keep going here. Since we have like our metadata, our retrieval augmented generation sources, let's actually get into the nitty and gritty of it and go to Azure OpenAI and actually decide to give all the data to the central part of the system, which is our LLM. And this is Azure OpenAI Studio right here. I already have some stuff set up here. So what you can do here is you have a specific deployment. And on that deployment, this is GPT-4 deployment, I can essentially go ahead and do some prompt engineering. I think this is the like new phrase people use where they actually tune those prompts. And And what I want here is to tell that model what it is, right? At the end of the day, I created an AI content creator, so I want to feed it all that data. So what I do is I phrase the problem. You're an AI content creator. Your goal is to entertain. You'll be given video transcript and metadata about the transcription, and your job is to create a plan, then react to the transcript. And from the metadata, if you are given a product, pick a brand and try to advertise it, add some value there. But it's also meant to create a plan of action, right? Because it may not have all the data readily available to it. For example, if I'm picking products from an internal company database, there is no knowledge in the LLM about that fact. So it would need to go ahead, retrieve some data from a database, go back, continue and re-infer and complete the prompt. So I give it an example as well. I'll give you the transcript, then I will give you a sentiment, and then I will give you some other metadata, in this case, like product laptop. And you need to create a plan, and then you need to create a response and advertise. And I sent our input here as the transcript, the sentiment, and the product we extracted from the language service. And as a result, I do get a plan. So its plan is to pull information on sunscreens from Wikipedia or a skincare API to provide context. This is probably not going to work. What is a skincare API, right? But we'll get to that in a moment. You need to find a brand of sunscreen with an affiliate link using the product's API. So this is probably an internal API, right? And it's the second step. Craft a funny commentary that ties into the video transcript and promote the sunscreen. And now it will hallucinate a bit because like it doesn't have those things. And it will actually create a response that it will comment on that hippo situation and how it's get eaten by lions. And then it will say, oh, actually, speaking of sunscreen, I found a great deal of Neutrogena Ultra Sear Dry Touch Sunscreen at Amazon, and it will try to advertise it. And this is our prototyping for the LLM. And then on the other side, we need to give it a voice and like close our applications loop a bit here. So we'll go to Speech Studio, pick a voice here, and go then to, so from the Speech Studio, if I select a voice, I can actually fine-tune that voice. There is the audio content creation studio here, which will let me, I will paste some text here, and it will let me break down and fine-tune how this will sound. I can add silences. I can add specific ways that this audio model like pronounces some phonemes. I can add reading rules, intonations. Maybe on the advertising side, I want it to be more like upbeat about the product, the rate and pitch which it speaks. So I can make this this AI content creator very like personalized. Seems like it has a personality about it. And then there are other things I could infuse to that model. I could infuse stuff like understand speech patterns from a pronunciation assessment endpoint. This is an Azure offering as well. So it can understand if Mr. Attenborough here, which is like speaking on that documentary, has an actual good pronunciation and make fun of him or comment on it, give it a bit of a flair. So like your imagination is the limit here of what you can do with those tools. And all of these tools in our toolbox are actually in Azure AI Studio, and you can explore, fit them to your specific needs, add your own data to them. I will go back to Azure OpenAI and show you that essentially what you can do here is like bring your own data to this prototyping phase and even export like the Python code of how it will actually use this data source, because this is integrated with Azure data sources. So if I click here that, oh, you know what? I want this GPT-4 model to take a data source for Azure Blob, Azure Cosmos DB, Azure AI Search, so some type of SQL or no SQL database, it can actually have access to that data, and I can then do better retrieval augmented generation there. And those are some of the tools in our toolbox. The last thing I'm going to say is maybe you are not like fully into like getting all the Microsoft specific models, right? And you want some models from the catalog. You can easily do that. I showed you before how deployment is easy here, but there's also benchmarking, right? So I can go ahead and say, oh, you know what? Let me benchmark, show some benchmark results of how GPT-4 compares to like 3.5 Turbo, right? And it will give me like some benchmarking results and the use cases and the data sets and how they perform in terms of accuracy.
A question is in the line. Can I export the app as Python code from the playground?
Of course, yeah. If I go back to the playground here, there's this view code button, which right now I cannot show you because this exposes an endpoint. But trust me when I say that this is actually what will be shown. You can get the Python code, and you can also get Python and C# code from those. And or you can actually export the settings in a JSON file to use that to actually influence the Azure infrastructure with PowerShell and onboard your services and set them up accordingly. And yeah, the playground will give you all those capabilities, and the playground will also give you your deployments and the models you currently have. I don't only have GPT-4 here. I have ADA as well to convert to embeddings, GPT 3.5 Turbo, so I can deploy those models, and their URL is actually my resource, right? It's a very specific URL that I use. I don't go to the public OpenAI URL here. I go to my Azure OpenAI service URL. You can check my deployments as well, what do I have in terms of models and how I configured my deployments, my quotas and data files as well, and completion point and full-fledged chat endpoints here. Something broke. Okay, we're back. Okay, and also I can tune the parameters as well. So for this example that we worked on before, I probably want the temperature of 1, right? I want the model to go crazy. And I can fine tune all those. And when I click on view code, all those parameters and setup will be outputted as well.
I have a question myself, Ioannis, because OpenAI released last week few additional models. I mean, the GPT-4 Turbo and also this 4V for Vision. Are they already available, or is there any public information about when it will be available in Azure?
I don't have that information, and I cannot speak for the Azure OpenAI team. Right now, I don't think it is, but don't take my word on it. There's Microsoft Ignite these days, so a lot of things I think will be announced. But in general, Azure OpenAI tends to onboard stuff as they come to OpenAI endpoints. For example, we had the functions OpenAI introducing functions and stuff like that to their endpoint. Azure OpenAI supports that, right? So you can expect it.
Thank you.
Yeah.
Yeah.
Okay. And with that, I will go back to actually discuss about how are we going to orchestrate that system. And let me go back to my PowerPoint here. There we go. So let's move on to the orchestration. We discussed all the different parts of the application. Let's try to put them together in a system now, because what we did was just prototyping. And we start with some definitions. What's orchestration? What's a plugin, which we're going to talk about. I think you will have heard those things because there are two very big frameworks working on those problem statements right now, and it's LangChain and Semantic Kernel, which is both kind of orchestration frameworks. And they use terms like plugins or skills, which is the plugins equivalent of LangChain. And even OpenAI is actually with their newest announcements getting into different agents and how to orchestrate between. They have a couple of proposals of global agents that talk to other agents and stuff like that. So it's in the very forefront of what's going on in this space right now. So what is an orchestrator? Let's break it down. And for those of you that are familiar with systems design, it's essentially around the realm of what we do with like API orchestration and service orchestration. So we have we take an input in the form of text, because we are talking about text inputs and LLMs. We will produce a plan of execution for this input using GPT-4 probably, which is the best like plan creator in terms of LLMs right now. We figure out the request and the intents, what's meant to be resolved there. And then we'll understand what capabilities exist to resolve those intents and execute on this plan and return a response or action. This is our system, essentially. This is what orchestration needs to do. Orchestration needs to do. And plugins, which are sometimes referred as skills, are like the capabilities of our system. We talked about a product API before, right? This product API is one of the capabilities of our system. And those are very important because you've seen semantic kernel and you've seen LangChain, but a lot of the times you need to integrate those into your systems. What I'd like to say generally is that the distributed systems are not going away in the generative AI era, right? So companies will always have their databases in there, and user will have the personal data, and you will need applications specifically to interact with this realm. Even though we're getting more ML-centric and more generative AI-centric, you will always need to interact with a distributed world. So those capabilities, those are like APIs and services that are already in existence, will not go away, but they will be infused with ML or the other way around. And that's what ML orchestration is about. Enable like this hybrid like software engineering and ML engineering system. And let's look at the plugin orchestration of what we just did, right? And this is integrating disparate AI capabilities into a unified experience. We want that content creator to seem like one entity at the end of the day. But its process is much more complex like that. And let's follow here the diagram, and I'll explain what each step does. So first of all, we had the transcript as an input. And this goes to a backend, of course. We leverage the APIs that we talked about to actually use them in our backend. All the code can be viewed and exported in C#, so that should be easy for like at least a C# oriented backend. And this request goes to the backend. And first, what we did is we did a couple of analyses there. We analyzed sentiment, we extracted entities, so we enhanced the prompts, right? This is the resource augmented generation sources. So we took an input, but we needed to do analysis on that input to enhance it and make it better. And then we go into the planning phase. As you saw, like we added those metadata into our prompt, and then we told GPT-4 to plan out some actions, but we never talked about how to resolve those steps in the plan, right? And what's the trick there? And that's what semantic kernel and LangChain actually offers, right? A framework with which to resolve those. And that's actually what OpenAI does with its plugins as well and its plugin libraries. It offers a framework to easily resolve some type of action. But in a lot of cases, you will need your own, not framework, but at least your solutions to integrate with your APIs. There are a million reasons for that. You may have like internal company systems. You may have like data you cannot expose to public APIs, and so on and so forth. So those orchestration systems, a lot of the times, need to be like orchestrated in your backend, especially if you like want to own your data pipelines, right? Which is in sample applications and a lot of startups is not important. But in Microsoft and in general, when you go into distributed at scale in production systems, this is not realistic, because you have like cross different rules across geographies. There's other laws for EU data and other laws for US data. So it starts getting more complex than just calling an API and passing your data to it. So with that plan in mind, we'll continue our orchestration story here. We have each step of the plan broken down by GPT-4. Now, how do we convert that step into a useful API, right? We had the phrase, I will use the Wikipedia API to get information about the sunscreen, right? How do we convert this to actual useful information? And this is where intent classification comes into play, where we'll classify that sentence and convert it to an API call. And there are a couple of ways to do this with Azure as well. There is the Azure AI Search service, which actually supports vector queries. And you can have a vector database where you hit that vector database with a new input. And like doing cosine similarity, you can get the top K most semantically correlated results to that query. And I'll talk briefly about it in the next slides. But essentially what you have here is you vectorize your plugin registry, like what capabilities does your system has. We have a Wikipedia API, we have a product API, and so on and so forth. And when one step of the plan comes in, you classify the step, which API is better to handle that, or another ML model maybe. Maybe you have like another ML model or an in-house ML model that can handle that request, and you want to add to the loop. And that plugin is selected for the next step. For the first step, we select the Wikipedia API, we execute the API, we get information back, and back to the planning phase we go with the first step resolved, and we go to the next and the next and the next until the plan is resolved. And then GPT-4 will take this plan with all the resolved information and actually produce a valuable input-output for us with information about sunscreen from Wikipedia and a product affiliate link, and it will try to get its viewers to buy that. And that's an orchestration system, and it can be abstracted to whatever thing you want, right? The plugins that don't need to be APIs. They can be ML models, they can be your services, they can be whatever. But at the core of this system here, and that's what we're gonna talk about next, and I think this is very different for software engineers nowadays. At the core, there's this intent classification process, right? Which is a very like non-deterministic process that happens in a backend. Backends tend to be deterministic. Like you run integration tests, and if the user clicks that button, that API gets executed. Like I know how the data flows in the system, and with this system, that's very hard to do. Especially if you have APIs, maybe you could get away with it. But even if you have other ML models in the loop that call other intent classification services and so on and so forth, this becomes too complex to be deterministic. So what's this intent classification process? And I'm sure a lot of you are very familiar with it, but for those of you who are not, intent classification essentially is the process of matching semantically one phrase to another. And well, let's say we have the phrase "what's the weather in New York?" So the system needs to classify a find weather intent, and New York is the argument to be classified. There are two ways to do this, and I've seen both. You can use completion models. So you can use GPT-4 or GPT-3 to actually do classification. If you ask GPT-3, here's a list of APIs, does this phrase get resolved with one of those? It will answer. But this is like going at the problem with a bazooka, essentially. It's a very large and expensive model. And as systems engineers and software engineers, we need to take that into account, right? Or you can use embeddings and solve the problem this way. So this is a very simplified intent classification process. And what happens is we have that text input, what's the weather like in New York? We convert it to embeddings, and we have some embeddings already saved in our databases. Some of them come from APIs, some of them come for other ML models, some of them come for just functions that we want to execute in our backend or services. And we go into that vector space, we calculate the cosine similarity, and we get some amount of results back. And then we can say, oh, you know what? Probably the most semantically correlated result is what we want executed there. And I won't go deeper into this. This is simplified enough, I think. But you can use Azure AI Azure AI Search to actually do that for you. Just one service, one SDK you call, and you can resolve that pretty easily. And that's our system, essentially. That's the orchestration system using mainly embeddings as its core to resolve those intents and orchestrate this whole area of, I'm using APIs, ML models, and other stuff to create a cohesive system. So I'm going to skip that. Actually, it's just a it's a slide I like about from promptengineering.org. When to like use few shot, when to use zero shot, when do you need fine tuning, when you're thinking of breaking down a system, which I find like very useful a lot of the times. And I'm gonna go to system considerations, which is some like real world actual things that we face in production, and especially in large scale production, right? And when you're getting to like create a sample project, or you're getting started, you most probably won't face that, but can become real pains if you if your application goes into production. First of all, with those orchestration systems, either you have like an orchestration that you built, or using semantic kernel or LangChain, or you're using, I don't know, 10 GPT models now that OpenAI has that that like specialized agents. There is the issue of cumulative latency, right? You all know that like an inference call may take from a couple of milliseconds to a couple of seconds. In terms of system design and like backend latency, this is a lifetime. Especially like if you have in your like if you didn't calculate your orchestration correctly, and now you have like a system of 10 models that do inferences. Now your cumulative latency becomes so huge. So you need to take that into account when essentially you're utilizing chains of models. And there are ways to tackle that in terms of systems, like distill your models, maybe use another model, not an LLM, like we talked about with embeddings and large language models for intent classification, but you can also reduce perceived latency. And you will have seen that in what OpenAI does, right? What ChatGPT will do for you if you go into their system, it will return the response token by token. So it seems like it's writing. A lot of the times when we use that API, though, we just get an asynchronous text response back, right? So imagine if ChatGPT needed to complete its answer before it shows it to you, right? It would seem like a huge latency service, but because they're writing back to you, and because this is an intelligent system, and it tricks you kind of that, oh, it's thinking, it's compiling an answer, the perceived latency is way lower now. And you can find ways in your applications to reduce perceived latency without actually affecting the latency of your real system. Those can be thinking indicators, or conveying what your skills are doing. Oh, I'm gonna search Wikipedia, and now you update the user constantly. So the perceived latency is way lower. Then there's cost optimization. Like most of those models are very costly, and you need to lower inference cost. And for that, you can actually do two things. First of all, think about what cost to benefit is for you, right? Maybe you don't need that model. Maybe you can get away with GPT 3.5 or a Llama model. Then you need to like think about model distillation. Like, can you break down your model essentially? Maybe a fine-tuned cheaper model can do the trick for you. Then there's prompt caching, which is a big thing, especially in production systems, and this goes a lot for welcome messages that chat experiences give, because like most of the times, like there is a set of things that users talk about in the first couple of messages, so you can maybe get away with caching, but this becomes tricky because like there is a very big sensitivity to input variation. You cannot tell that this is similar to something else. And of course, you're gonna have stale response, so you may make your system seem less intelligent than it is. And there's the like prompt engineering quote unquote side of things, which is you need to evaluate the cost of your prompt management, meaning that if you're prompt engineering the system, you're not fine tuning, you're not doing anything like that, you're just gonna give a very huge system context, like we saw in that chat playground, and you're gonna instruct it really hard. Now, the token limitations of that may hit you really, really fast, right? Because the system prompt is actually part of every follow-up inference call. So a couple of things may happen. First of all, you may reduce the user's token window into like nothing. So you've created the system and the user's input is taken into account minimally, or they can write maybe 150 characters and that's it for them, because like your prompt engineering is so huge. So you need to take into account leftover capacity. Then there is like the multi-turn authoring. Like you reply, and then you have an answer, and then you reply again. And based on how much tokens you've used, this conversation may have a long history, like a long memory in terms of how how many answers before it can take into account, or a very short one. So that's a big consideration of your LLM and how you interact with that API. Yeah, and a phrase we like to say is that we've moved a bit from deterministic, rule-based programming to a more probabilistic, data-driven kind of decision making, right? In the area of generative AI, especially. So engineers tend to think of those problems in misclassification or errors in intent classification as error states. And the concept, and I think the mentality here is changing, that you know what, even failure states of those models are an opportunity for you to interact with a user and actually continue the loop of the system. Maybe you don't have enough information. Maybe you need context. These are not error states. These are states where you refine the system either through user input or retrieval augmented generation, getting more metadata from the user. So I would tend to I would urge you to think your exceptions a bit more like that. That's pretty much it from my side. If you have any questions or you want to discuss anything, feel free to see them in the chat.
Yes, of course, we have questions, Ioannis. So there is one, a general one. I think you were talking about the intent classification or intent classifier. How does that compare to OpenAI's function calling, or is it a substitute, one of the other?
Yeah, so it's not a direct substitute, right? So I'm not sure how they implement function calling under the hood, right? But essentially, intent classification with embeddings it's a process that used to happen before LLMs even. So essentially, what you have is you do use OpenAI models to do that, right? For example, in order to get into the intent classification process, you need to convert that text into embeddings. And the way that gets converted is with text embedding ADA, which is an OpenAI model. And what it gives you is it gives you a vector representation of your text. Now, in vector space, how this gets vectorized is OpenAI's approach to vectorization, right? So it infuses the semantic meaning on that vector. And when you get to populate that vector space, now you have, if you do it with text embeddings ADA at least, you have a vector space that vectors are populated with the semantic meaning that's behind ADA. So when you get a new input in there, the closest things that you're going to get back are the closest semantic correlated things based on what ADA vectorizes, right? And that's how you get to classify the intent of a plugin or anything else. It's a very fast process because essentially what you're doing is you're comparing vectors. This is so fast compared especially to an LLM and how that happens. Now, in terms of function calling, I think it's two different things. With function calling, you actually let the LLM decide to call a specific function. And that's useful a lot of the times for cases oh, I want to form my output as a JSON file maybe, and stuff like that. But when you want to call APIs and you're not sure where to go with that call, you can use embeddings to actually get the most semantically similar API to your input. Now, if function calling under the hood uses embeddings, maybe, but I'm not sure. I'm not internal in OpenAI, at least. I don't know.
Okay, yeah, thanks a lot. We have a few questions which were placed earlier, but requested to be placed at the end. What kind of compute do I need to for running Whisper?
In terms of resources, so this is a bit tricky. I can link I can link the pricing here for those for Azure ML. It's you would need, in order to deploy those models, essentially you would need GPU capacity, right? And to run inference, you would need GPU capacity. Microsoft offers that. Azure ML as a platform actually lets you choose. I think ML Studio lets you choose a cluster to work on with provisioned GPUs, and you can select whatever cluster you want and get Whisper under that cluster. Of course, more resource clusters will run Whisper faster. Now, the cutoff limit, like what the cheapest cluster maybe or the smallest cluster you can use Whisper on, I'm not so sure. I'm not a product manager, so but I can link you those pricing tiers and like those cluster tiers of what GPUs its Azure ML cluster has, so you can actually like see for yourself. I think they may have also when you try to deploy, they may have like yeah, I'm sure they will warn you about if you're using a cluster that's low in resources, and this would not work with Whisper or whatever other model. So when you go into push that deploy button, if you select a cluster that's like, I don't know, 1A100 and like it cannot do it, it will warn you that, oh, you know what, you're using a tier that's not that's poor in resources for that model. I know it does it for at least some of them and for some pricing tiers.
All right. And what are the main differences, now this is unrelated, between Azure ML Studio, including prompt flow, and AI Studio, use case-wise?
Use case-wise, I think there are two separate entities, and I think Azure AI Studio is a new thing. It's a new kid on the block, and I think it stems from the need of consolidating information. Like I think in a lot of cloud services, you see like information like thrown around. You don't know where to search to find a specific capability. I think what Azure AI Studio aims to do, or at least what it does for me personally, when I work on those stuff, is it consolidates the information, right? But when I go to that catalog, that models catalog that I showed you, that's an Azure ML thing, right? And essentially, if you want like to handle the deployments of those models and the data pipelines of those models, you would go to Azure ML Studio. Azure ML Studio is a tool essentially to handle your deployments, pipelines, and like even edit like the Python scripts for your models. Azure AI Studio, as it stands currently, is a consolidation of resources so you can easily use them.
So one offers more customization than the other, I guess.
Exactly.
Yeah.
Like you could provision the model, but you would go to Azure ML to like at the end of the day, like edit all the fine-tune details. Again, I don't know what they have in mind when they get out of preview. I hope they do a lot of stuff with it, but right now, you can consolidate your research, but if you want like fine-tuning of like a lot of stuff or even fine-tuning models, you would go to ML Studio.
Okay, now we have two questions related to cost. Do you happen to know what kind of GPU I can access in the Azure free trial? So $200 to burn.
Okay, I'm so sorry that I cannot answer that.
Right?
One of the things is like we are very spoiled to not be using free tiers in Azure, like as an engineer, right? So I'm not sure. A product manager would be better answering that. But again, I can link you that information for sure.
Yeah, and I think there is a very good Azure calculator. If you search in Google or in Bing, you will find it, and I think you can make your own trials. And the same is the next question, how to invest $50 monthly. I think it goes in that direction. You can. I think you should have a look at the calculator. There is one more question below. Does Microsoft Copilot support to build these applications using RAG, so retrieval augmented generation, semantic search, or does offer orchestration functions?
So Microsoft Copilot is actually like a result of those systems, right? So Copilot, and again, not work on that system. I don't know where they're taking it, honestly. But essentially, this is the result of like background work done, like we talked about, right? Like most Copilots use resource augmented generation to like get data and make it useful for you, right? So, and I cannot speak specifics here in terms of like what Copilot does. I don't know them, but essentially what offerings are in terms of Copilots are LLMs that can interact with your data or your company's data, and they can like contextualize those data and give it back to you. And we use the term compilot internally to describe that, a process that like through retrieval augmented generation actually helps you achieve a goal, right? That's why it's your copilot. It stands with you next to your data that maybe you or your company has, and contextualizes on those and actually will give you a response. Now, if they're gonna, I think they're gonna infuse more plugins maybe and stuff like that into Microsoft Copilot, but I'm not so sure again.
Okay, and there's one question which I believe is very tricky. What would be a sufficiently big enough small LLM for a rack? I think it depends on the type of data, right?
Yeah, it really depends on the type of data and how you fine tune it. I think there are a couple of ones that you can run maybe in a 4090 nowadays. So I think there are some fine tunes of is it Llama that are small enough to actually of Llama 7B, I think, that can run on those. I don't know how you would use those, because like there is a cutoff point for LLMs that actually become useful and don't like produce a bit of garbage, right? I don't think currently you can run it on a rack. It depends on your rack, of course. Like, I don't know where you're at. Maybe you have like a couple of 51 i100s and you can do that. But in general, I would say it's very difficult to get value out of those systems. Maybe for prototyping a bit, but again, I would advise against doing that, because like the synthetic results you would get might not translate to your future product.
Okay, so we need to move towards the end. I have to say, Ioannis, I had the feeling of receiving a summary of what I have learned in the last 6 months or so, and some additional new things. So really, really great. Thank you for that condensed information. And to close today, just one more reminder of what is coming up. Next Monday, the community call. In December, we have 2 great expert talks. And again, very soon we will have hands-on free live courses from very beginners to more advanced. And we are searching, we have few course instructors. We are searching for a few more. And again, you can, or you should subscribe in YouTube, follow us in Meetup. I think if you didn't follow us in Meetup, I'm not sure how you got here. I think you are already doing that. And the LinkedIn page is also a good source for getting to know what's going on. And with that, again, thank you so much, Ioannis. Thank you for the great questions. I see some reactions also live, which is nice to see. And with that, we close. I wish you a good evening and see you next time.
Good evening, everyone. Thanks a lot for having me, Carlos.
Bye-bye.